do repeat, but hey, I got some new ones here too. Circumference formula not given to you on Tuesday. That's on you. That's on you. 9 pi times my diameter. Good work. Pi d. I may ask you to leave your answer in terms of pi. We're all comfortable doing that. Okay, or nearest tenth, nearest hundredth. Length of an arc formula. How do I find the length of an arc? 11, length of an arc.
The measure of the arc, trying to find over 360 times the circumference.
There you go. Good. Measure the arc over 360 times my pi d circumference. Quickly, what type of units does that have to be in the measure of the arc? Degrees. Yep. And I keep asking because it's going to get a little change up for you today. Degrees. Speaking of measure of the arc, how do I find it? How do I find it? Using what theorem? The measure of the arc is always the same, always equal to 20. There you go. Measure of the central angle. Good. All right, we're all good there. Going. All right, let's go vocab now. Vocab. Now it's circle K. Tell me something about point K. Circle K, point K, 4. No, going back. 24. Center, thank you. Let's use that vocabulary. Center. If I had you draw radius KS, what do you tell me to do? Radius KS. Be descriptive here for me. 4. 22. I'm making it difficult for you. On the circle. Just say on the circle. Okay? Radius got to come from the center to a point on the circle. Diameter, GH, talk to me. Looking for something specific here. 3.
G and H are on the circle and it goes through the center.
That's the important part. A diameter has to go through the center. That's great that G and H are on the circle. That's great. Let's put an H there, G here. But it's got to go through the circle. Yep. All good? And then what about chord WV? 13, chord WV. Talk to me.
2 points that don't go through the center.
They can, though. They can. All right. But the 2 points have to be somewhere on the circle. It can go through the center. A diameter is a chord. In fact, it's the longest chord in a circle. But the endpoints have to be on the circle for a chord. All good. Oh, we got more from yesterday. I have a degree measure. How do I change it to radians? Multiply it by 8. I have a degree measure. I want to change it to radians. Multiply it by pi over 180. Do I want the decimal that comes out of your calculator? No, I want it in terms of pi. In terms of pi, your radians. All right, go in reverse now. What if I have radians and I want to change it to degrees? Now I'm going to multiply it by 9. 180 over pi. Hopefully the pi's cancel. Sometimes they won't, because radians don't always have to have pi with them. That's just 3 days right there. That's just 3 days. All that we went over. Hey, these two, I'll give it to you on the quiz next week. All right? You get the formula sheet, which has these conversions on it. Anything right there? Homework. We're all good. I know I went over this at the end of class, the clock question. We're all good. We know what we're talking about. If both of these are the hour hands, I was looking for this angle measure right here. All right, that angle measure right there. All right, not the minute hand going around and around and around from 1 to 9 o'clock. No, the hour hand moving from 1 to 9. Clock question going to be on the quiz next week somehow. It's going to be a little bit more difficult than this one, though. I do have a challenge question for you. Ready? Could you find me the length of the arc that the hour hand travels? Could you find me how long this arc is? Ooh. How long that arc is. Go to the formula for length of an arc. Length of an arc formula. How could you help me find how long that arc is from 1 to 9? What's the first part of the formula say? 13. First part of the formula says what? Measure of the arc. And that's what you guys found in your homework. What is the measure of this arc? In degrees. 9. What was it? 240 over 360 times pi. What other piece of info would I need to give you here? You couldn't solve this right now, but what would I need to give you in addition? Mahmoud, go ahead. Basically, what's the length of the hour hand? And then that would be your radius. Okay? So that's how I would find the length of the arc from 1 to 9. We're getting, it's no joke here. Hopefully my warning at the beginning of the unit is starting to come to fruition here. I was pretty truthful there. Anything else on last night's homework? Changing radians to degrees, degrees to radians. Because I'm going to have you do it again today, just in a different way. All good? Okay, I saw most of you do this yesterday, so I don't need to waste time and walk around. So why don't we just get right to today's stuff? You guys see the topic today. Isn't that something we already talked about? Arc length? Don't you guys have a formula for arc length? You do, but only if your angle's in degrees. What happens if it's in radians, right? If it's in radians, I cannot use this formula if it's in radians. All right? So what I'm going to show you guys today is, hey, there's a different formula we could use if the angle actually is in radians. All right, here it is. Here's your formula. If the angle's in radians and you want to find the arc length, I start out with theta. What's theta mean? That's your central angle already in radians. All right, so theta is the central angle in radians. Theta is equal to, let me finish the formula for you, S over R. There's the formula for arc length if the angle's in radians. If it's in degrees, you got another one we just did on the second day of this unit. All right, what's the other parts mean here? S, ready? S is your arc length. S is the arc length. R is, any guesses? Radius length. There you go. Again, how to find arc length if your angle's in radians. If it's in degrees, you know the formula already from day 2. All right, ready to use it. I'm going to start calling on some of you guys now. Look at my circle. I'm trying to find the arc length, S. But what is the angle in? What's the angle measure in right now? Pi over 3 what? 18. Pi over 3? Radians. Radians. So now I'm going to use my new formula. Theta equals S over R. Theta equals S over R. What's going in for theta now? What's going in for theta here? 18 again. My angle in radians, which is?
Pi over 3.
Pi over 3. So everyone ready? In for theta, pi over 3 equals S for the arc length. That's what we're trying to find, so leave it S. Or if you guys want to change it to another variable, feel free. Over radius, 5. How do you solve these? Come on. We got a Regents coming up in 3 months. 90 days. Paul, how do I solve these? Cross multiply. Yep, because I have the equal sign in between. So I get 3s equals 5 pi. Divide both sides by 3. Now, look, hey, there's rounding directions, isn't there? Nearest hundredth, so don't leave it in terms of pi. Actually find out 5 pi divided by 3. 5 pi divided by 3. Get your calcs out. I don't do this stuff for free here. Hundredth. So you're going to give me a number followed by a decimal place with 2 numbers after it. So when you're ready, give me that number. Oh, 21. Got it. Good work. Before I get to the second one, I want to ask you guys this because this is my point today. Do I even need this formula? Or can I get away with using the length of an arc formula? There we go. Using the length of an arc. I'm going to regret it. Nope, good. Can I get away with using this formula? Anybody? Could I still use this formula? The answer is yes, with a but though. What are you going to have to do with the pi over 3 before you use this formula? What do I need to do to the pi over 3 before I use that formula? Caitlin?
You have to put it in degrees.
I got to put it in degrees. Do you guys have the ability to take a radian and put it in degrees? Yeah, from yesterday. All right, so I'm just trying to show you guys, I'm going to allow you to do what you want. I am showing you this new formula. If you want to use it, great. If not, just make sure you have the ability to convert radians to degrees. Okay? You do not have to memorize both. Do what you're comfortable with. All right? And by the end of today, hopefully you feel comfortable doing something. All right, number 2, angles in radians. Convert it, use the other formula, or use my new formula today. Theta equals S over R. Again, only use this, though, if your angle's in radians. All right, what are we plugging in for theta here? Woo! 12. What are we plugging in for theta?
10 pi over 9.
Darn right we are. 10 pi over 9 equals arc length. We're trying to find again. Radius is 27. Cross multiply. Divide by 9. Yeah. 10 pi times 27 divided by 9. When you're ready, how about nearest hundredth here? When you're ready, 13.
94.2. I'm not sure about that.
Need hundredth, so one more number. 94, that's nearest tenth. 94.2. 5 meters. We all good? All right, moving on. Okay, now I want you to find the angle. We're going to find it in radians and degrees. I think I know the answer to this, but I'm still going to ask, and you guys get to have an opinion. Did I say what order I needed it in? Radians, degrees, what comes first? No? So would you guys rather use the day 2 formula, measure over 360 times circumference, or theta equals S over R to start? Doesn't matter what we use. Anybody got a preference? Why would we want to talk, right? Let air move through your body. It's all right. Through your throat. Anybody have a preference? Jonathan?
Theta.
Is that your preference, Caitlin? All right, that's what I figured. Theta equals S. Okay. Okay, I'm going to still challenge you, though. If we're going to use that, will my final answer be in degrees or radians? If we're going to use theta equals S over R right now, will my final answer be in degrees or radians? Oh, 17. Radians. All right, let's do it. Theta equals S over R. And also, I'm making a point of this. This is the length of the arc, not the measure, because some people will say, oh, this is easy. This is always equal to the central angle, so that's 8 pi. No. Everyone, this is the length of the arc, not the measure, the length of the arc. All good? So my answer is not automatically 8 pi. Theta is going to stay theta because I'm solving for it. What am I plugging in for S now? S is, it's already up top, but arc length. What's my arc length here? Hook me up, 22? 8 pi, good work. Over my radius, 16. Tammy, did you just tell me it was going to be in radians?
Yeah.
Okay, then I better have it in terms of pi then. If you're giving me radians as an answer, it better be in terms of pi. What do you got here for me? 8 pi over 16 reduces down to... What is that in radians? We did all this yesterday too. 5? 0.5. Is it all right if I keep it a half, Greg? Is that all right with you? I don't want to offend you. I'm going to pi over 2. You can put 0.5 pi. That's fine. So here you go. I almost did that. Radians, pi over 2. Now what's the angle in degrees? Why am I doing this to you, making your life miserable? Because I need you to be able to convert to. So in degrees, this is going back to yesterday now. Pi over 2 times what? What am I going to multiply pi over 2 by to get it into degrees? 6, you're up. 180 over pi. And nice here, everyone. Nice. The pi's cancel. See ya. See ya. Remember, we're not cross multiplying. 180 over 2. This is not cross multiplication here. You're better than that. 21. Pi over 2 is what in degrees? When you're ready. 90 degrees. Yep. Pi over 2, same as 90. So that's a 90-degree angle up there. Everyone all right? All right, now this is going to get algebraically a little tougher. So I need some algebra. Any algebra studs in the house? That's right. You just cheated your way through Algebra 1 last year, virtually. Right? That's what I heard from period 2. All your take-home tests. Yeah. Had a wake-up call when you walked in here first day of school. All right. Theta equals, what's your S value here? The arc length? Arc length. 24 arc length? Yeah, I'm going to plug that in for S. 15 pi over 7 over the radius of 5. And this is where algebraically we got to remind ourselves, what do I do in this case? Because you don't plug this in your calculator, right? Because you guys know if this is radians, I need what in my answer? A pi. So how do I deal with all those fractions up there? Anybody remember how to deal with them back in the day? Fraction divided by another one? Anything? Jonathan?
Maybe multiply each side by 5.
No. Because if I multiply both, now I'm getting 5 theta over here. And I want to try to just keep that theta. Okay? Anybody remember keep the top? Change the division to multiplication and do what with the bottom number? Flip? No? Skip? I don't know. What did they have a fancy name for it back in the day? Skip, flip, keep, change, flip. Whatever fancy little lingo they had. Yeah. There you go. That's what happens when you divide a fraction by a fraction. And look, I'm not going to lie to you guys here and sit up here like you have to do it this way. You know what you can do too? Put this whole thing in your calculator without the pi. Do 15/7 divided by 5 in your calculator, and it'll give you the fraction you need. I'm not going to lie to you guys. That's what you can do too. All right, instead of doing the skip and flip stuff. All right, so you know pi's got to be in your answer, so put the darn pi there and then plug the rest into your calculator. You guys have them, use them. So all of that reduces down to what fraction? 15. Got that fraction?
3 fifths.
3.
Fifths.
Sure it's fifths? What is it? I got 3 sevenths, yeah. 3 pi over 7. All right, go ahead, everyone. Put it in degrees now. Go nearest tenth for me here, because I know you're going to get a decimal. Go nearest tenth for the degree measure. Nearest tenth, what is that as a decimal? 11.
77.1 degrees.
77.1. Good work, good work. Whew. All right, all good. Any issues? You choose what's best for you. You want to go one formula, but be able to convert, fine. Or if you want to know both, so you never have to convert, that's fine too. All right. We need a life lesson before we do this problem. A life lesson. Yes, no? We know what we're dealing with here? Pendulum? Every year I don't assume that people know this. Oh. Sorry. Pendulum? Back and forth? Work with yes, no, maybe. Oh, maybe this will help. I go cartoon version for you guys. Or not. Hey, no, what happened to my cartoon version? Definitely just clicked on that. Cartoon.
Just unclicked on it. It was already clicked.
Oh, it's already there? Oh, thank you. Cartoon. Yeah, how about that's cute, isn't it? Little fire truck with the fire hydrant, or the rainbow with the little cloud as the pendulum. That's so. This would be the answer to what you cannot expect to be in Mr. Carlino's house. The answer to that question. Oh yeah, definitely the rainbow with the unicorn. Okay. Yeah, my thought exactly. $36 for this thing. Are you kidding me? You're gonna spend $36 on that.
I think it's worth buying.
Fast fashion website.
$36.
It's actually cheaper than it would be. $26.
Yeah. Now add in the $26 now for shipping. Are you kidding me?
That's actually kind of nice. I feel like you should get it and put it in your room. You should hang it up in here.
In case you needed to know that it actually moved, it moved.
I feel like making it. Usually like some wood.
Rip off.
That's so
They
sweet.
also need hardware.
Oh, that's cute because everyone has one of those in their room. Oh, a little sun in the cloud. Yeah, great. All right, we're good.
Oh.
All right, clearance sale. We got it. HD transparent lace. All right, we're good. All right, so everyone's good with the pendulum now. All right, or the cute ones there. Anyway. All right, so going back here, it's going to swing through an angle. So back and forth, it makes an angle of 2.5 radians. So I gave you this wonderful diagram here of the pendulum. You guys can make a little pendulum yourself there. And it's going to swing back and forth, whether it's to the right back or to the left back. You decide that on your own. So back and forth, it creates an angle. Take a look. Everyone see what I'm talking about? The angle that it makes going back and forth of 2.5 radians. And it travels through an arc of 50 centimeters. Where should I put that 50? It travels through an arc of 50 centimeters. Where am I putting the 50? On the arc. Find the length of the pendulum. Now I try to make a little real life out of this, right? Because I didn't put the common vocabulary term here. But the length of the pendulum is me asking you guys what? Find the radius. Exactly. I don't need to put radius. I'm asking for the length of the pendulum, which is represented by the radius. Hey, anybody want to convert so I can use the other formula? Anybody? Can we convert and use the other formula? No? You're just going to say theta equals S over R? Nobody wants to convert with me? No? Okay. What? Nothing exciting. All right, what are you plugging in for theta then? 13? What are we plugging in for theta?
50.
Theta is my arc length or angle measure?
Arc length. Or angle length. The central angle.
Okay, let's redo that question now. What's my central angle in radians?
2.5.
2.5. What's getting plugged in for S now? 6. 50, the arc length over R, and now we can cross multiply. We got in centimeters because there is no rounding directions needed here. It'd just be a nice whole number, I hope. When you're ready, how long's the pendulum? 6 again, when you're ready there, Lauren.
20 centimeters.
20 centimeters. Thank you for the units. Questions? All right, one slight change on number 6. I'm sure you guys know how to handle it, but I just want to be confident myself. Can you guys make a central angle of 3.5 radians right now? A central angle, meaning where's the vertex? Right in the center. So everyone put your center point, make an angle out of it. That's 3.5 radians. And it intercepts, that means makes, intercepts, makes an arc of 24.5 centimeters. Diameter? 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 My formulas don't. Can I still use theta equals S over R? Do I have to use the other one because it has D in it? Can I still use this one? And do what at the end, though? Solve for R, but multiply by 2. All right, we're good. Just making sure you guys don't get freaked out. You can still use this formula, solve for radius, and just multiply by 2 at the end. Hey, anybody want to convert? I should ask. Anybody want to convert so I can use the other formula with you? Get no takers today, but no takers converting. I don't know what your deal is, guys. 3.5 equals 224.5 over R. This should become a nice number here. R equals, we got there, Brendan, 7? Yeah. So diameter, 7 times 2, 14 centimeters. Whew. Anything before we get to the last one? And if you don't already, you're just going to hate this next one. Hate me for making you do it.
Why does it have to be done both ways?
Before we go, top of the page, two arc length formulas, right? One for degrees, one for radians. Just make sure we keep them separate. Do you have to memorize both? No. You can memorize one and be able to convert, or you can memorize both. Up to you. All right, I am going to force you to use both on this one, though. All right, yep, we got a cart. That's cute. Traveling at a radius of 2.4. Cart starts at A, stops at point B. What's the length of minor arc AB? What's the length of minor arc AB? So everyone knows what arc we're finding, right? This one right here, the minor one, less than 180. Everyone see 165 degrees. So can we start off with the arc length formula with degrees? Can we start off right there finding it? because you're going to have to do both. I want it both done in radians and in degrees. So we got degrees first, so let's do it. What am I going to do for my formula? 9, here we go. Arc measure. Over. Times. You're better than that. 4.8. All right, there it is. In degrees, how to find the length of an arc. It does say nearest meter, so plug it all in. I'm not looking for in terms of pi here. Nearest meter, so plug it all in. 1/10 of a meter. Relax back there. All right, relax. I actually don't have this answer, so I'm going to have to rely on somebody. Three, even when you're ready.
6.9 meters.
That is correct. I remember that from second period. Now I want you to use theta equals S over R. How much have we learned today? How much have we learned? Can I just take 165 and plug it in for theta? Can I do that? Hey, can I do that? Take 165, plug it in for theta, and go. No, you can only use this if theta's in what type of units? Radians, correct. So we're going to take 165 off to the side and turn it into radians by multiplying it by, what's the conversion? Come on! 15? God, yeah, you guys are fire. Leave it in terms of pi, right? Leave it in terms of pi when I get a radian out. 165 over 180, what's that reduced down to? Let me know when you're ready what the radian measure is. Ho, 1. When you're ready here, Meg, 165 over 180, what's it reduced down to? $165 over 180. Write my calculator in a fraction template. That'll tell me what it reduces down to. 11 pi over 12. There we go. So go back to theta. 11 pi over 12 equals S over 2.40. And I'm the only one that gets excited about this. The fact when I cross multiply and divide by 12, I get. I know I'm the only one that gets excited, but so 2.40 times 11 pi divided by 12. Oh, shocker, you still get 6.9 meters. Look at that. Doesn't matter what formula I use. Just proving my point today. Just make sure you're in the right units. Just make sure you're in the right units. All right. That's all I got for you. Your boy making an appearance right off the bat in the homework. Enjoy. Enjoy. Keep grinding away.